This tutorial is for 6th grade, Module 4, Lesson 16. In this lesson, we're going to solve inequalities and also graph them. When we were solving equations earlier, we always came up with an answer for the value of x. What we're going to find with inequalities is that there's more than one correct answer for our variable because of that greater than, less than symbol. The directions here say to replace the variable in each problem with the numbers below and circle the numbers that make true statements. Our first equation is x plus 2 is greater than 8. And I'm going to test these four numbers, 4, 6, 5, and 7, meaning I'm going to put each of those numbers in place of the x and see if it makes a true statement. Let's test the 4 first. So instead of saying x plus 2 is greater than 8, we'll say 4 plus 2 is greater than 8. Well, 4 plus 2 is 6. 6 is not greater than 8, so 4 does not work in this statement. Let's try the 6. 6 plus 2 is greater than 8. Well, 6 plus 2 equals 8, but it's not greater than 8, so that does not work. Now we'll try 5. 5 plus 2 is greater than 8. Well, 5 plus 2 is 7. 7 is not greater than 8. And let's try 7. 7 plus 2 is greater than 8. Well, since 7 plus 2 is 9, and 9 is greater than 8, then 7 works in that equation. It makes it a true statement. The next equation is x minus 3 is less than 5. Let's start with the 7 in place of the x. 7 minus 3 is less than 5. Well, 7 minus 3 is 4. 4 is less than 5, so 7 works in the statement. Now let's try the 6. 6 minus 3 is less than 5. 6 minus 3 is 3. 3 is less than 5, so 6 works in the statement. How about 8 minus 3 is less than 5? Well, 8 minus 3 equals 5, but it's not less than 5, so that does not work. And since 8 doesn't work, I know that 9 is not going to work either, because if I subtract 3 from 8, and it's not less than 5, then subtracting 3 from 9 would give me another number that's not less than 5. So 7 and 6 are the numbers that work in this statement. My next equation says x plus 4 is greater than or equal to 10. We're going to substitute 4 for the x. So 4 plus 4 is greater than or equal to 10. Well, 4 plus 4 is 8, so that does not work because it's not greater than 10. 6 plus 4 is greater than or equal to 10. Well, 6 plus 4 is equal to 10, so that does work. Then 8 plus 4 is greater than or equal to 10. Well, since 6 plus 4 equaled 10, then any number greater than 6 is going to give us a sum that's greater than 10. So I know that 8 will work in the statement and 7 will work as well. The last equation is x minus 2 is less than or equal to 8. So we'll start with 12. 12 minus 2 is less than or equal to 8. Well, 12 minus 2 is 10. 10 is not less than or equal to 8, so that's not going to work. 10 minus 2 is less than or equal to 8. Well, 10 minus 2 is 8, so that does work. How about 8 minus 2 is less than or equal to 8? 8 minus 2 is 6. 6 is less than 8. And then 9 minus 2 is less than or equal to 8. Well, 9 minus 2 is 7. 7 is less than 8. So in this statement, 10, 8, and 9 make true statements. In this section, we're just going to review how using inverse operations helped us find the value of x in these regular equations. My first equation is x minus 2 is equal to negative 8. We use the inverse operation to isolate the x. So instead of subtracting 2, I'm adding 2 to both sides to keep it balanced. That means x equals negative 6. In question B, I have x minus 9 equals negative 1. I'll add 9 to both sides, and that means x equals 8. So this is just a review of solving equations because we're going to use basically the same steps to solve inequalities. We'll solve this inequality and then we'll graph our answer on the number line. The equation says x minus 2 is greater than negative 8. Again, I'm going to isolate my variable, so I'm going to add 2 to both sides. Now I'm going to write my variable down, but instead of writing an equal sign, I'm going to keep the same sign that I had before. So I'm going to keep greater than, and then negative 8 plus 2 is negative 6. So any number that is greater than negative 6 will work in this equation. So now we have to graph that. Negative 6 will not work itself. So I'm going to put an open circle around negative 6. And then I'm going to put my arrow to the right of negative 6, because any number that's greater than negative 6 would work in this statement. Here's the graph that shows my solution. And we can test this out to prove it. So I can choose any of these numbers on my red line and put them in place of the x in the equation to make a true statement. So let's say we chose negative 1. That means that negative 1 minus 2 is greater than negative 8. Well, negative 1 minus 2 is negative 3, and negative 3 is greater than negative 8. So that solution works. Here's another example. This time my equation is x minus 9 is less than or equal to negative 1. Again, we'll isolate the x by using the inverse operations. Instead of subtracting 9, I'll add 9 to both sides. This gives me x on the left-hand side. Again, I'm going to keep the same symbol, so I'll put less than or equal to, and then negative 1 plus 9 equals 8. So my solution is x is less than or equal to 8. Because it's less than or equal to 8, we will count the 8 in our solution, and then all the numbers to the left will be part of the solution because those are the numbers that are less than 8. So we'll put our arrow on the left-hand side of the 8. And there's my solution. And again, we can choose any of these numbers on the red line to test it to see if it works. So let's choose 3. So I'm going to put a 3 in place of the x. 3 minus 9 is less than or equal to negative 1. 3 minus 9 is negative 6. Negative 6 is less than or equal to negative 1 because it is less than negative 1. So solving these inequalities is very similar to solving regular equations, except that we have more than one correct answer that we could put in place of the variable.